Hi there, I'm Sridhar Chandrasekharan, and I'm thrilled to introduce a study series on power transmission line construction. Drawing from my career experiences, this series aims to provide practical and theoretical insights that can be directly applied to real-world projects. This study is designed to help engineers and managers deepen their understanding of transmission line construction, enhance the quality of their work, take accountability for the tasks they oversee. We have started with the basics of electricity, how it's generated, its requirements, and its sources. From there, we'll progress through implementation, execution, and finally, project handover. Given the breadth of this topic, I've broken it into chapters which are released weekly. Along the way, we'll also explore key complementary areas such as engineering ethics, legal considerations, health and safety compliance, human resource management. These critical aspects will be seamlessly integrated into our technical discussions. Each week, I'll release a new video covering key technical topics, ethical questions, a thought-provoking quote to inspire reflection. Currently, we're in Chapter 6, focusing on the final stages of project management. There's still a lot to cover, so stay tuned for more. Disclaimer. Just a quick note. The content in these videos is meant for informational and basic educational purposes only. These videos aren't intended to provide professional advice or endorsements. This helps set the right expectations about the nature of what we're sharing, especially since we draw on material from various sources under the principle of fair use. In the previous study, up to Chapter 4, we laid a solid foundation by covering essential concepts such as electricity and power generation. We also delved into the prerequisite activities necessary for transmission line construction, including demand assessment, resource requirements, project planning, and the tendering and bidding processes. In Chapter 5, we started exploring about portion of project management, and now, in Chapter 6, we will be continuing our discussion about project management. Project Management Overview. In Chapter 5, we covered key aspects of project management, including topics such as contract finalization, establishing the project team, detailed project planning, and selecting a project office and site organization. In this chapter, we will continue with the remaining topics in project management. 5. Obtain necessary permits and approvals. Regulatory compliance. Apply for permits and approvals required by local, state, and federal agencies, including environmental permits and construction permits. Right-of-way access. Secure land access rights and negotiate with landowners, government entities, or other stakeholders as needed. 6. Arranging logistics. Transportation planning. Coordinate the transport of materials, equipment, and personnel to and from the site. Access roads and site access. Plan and build access roads if necessary, ensuring that all parts of the site are accessible for construction crews and equipment. 7th Route Survey. Detailed survey. Conduct a route survey to finalize the transmission line's path, evaluate terrain challenges, and gather data for design adjustments. Geotechnical investigations. Assess soil conditions and geological factors that may affect foundation design and tower placement. Eight. Soil investigation. Its primary purpose is to assess the soil's characteristics and suitability to support transmission tower foundations. Soil sampling. Samples are collected at proposed tower locations, usually through boreholes drilled at various depths. These samples provide insight into soil composition, density, and moisture content. Geotechnical report. The results of the soil investigation are compiled into a geotechnical report, which outlines the soil characteristics at each tower location and provides foundation design recommendations based on the data. 9. Detailed design, engineering and design work. Finalize the technical specifications for towers, foundations, conductor types, and other components. Compliance with standards. Ensure designs adhere to industry standards and safety regulations. We will conclude this chapter on project management with detailed design. In the next chapter, we will cover the remaining topics, including right-of-way acquisition, procurement and resource mobilization, implementation of safety and environmental protocols, documentation submission and approvals, and construction phase execution. Now, let us start the topics in detail, and starting with the fifth topic on project management, obtaining permits and approvals. Once the project office setup is underway, it becomes critical to obtain all necessary permits and approvals, ensuring regulatory compliance before commencing transmission line construction activities. While many of these arrangements fall under the client's responsibility, it is essential for the contractor to actively follow up and stay informed about the status of these approvals. This enables better planning and timely mobilization of resources. These approvals involve submitting permit requests at various governmental levels, either independently or in coordination with the client, to secure land access rights. Additionally, contractors may need to negotiate with stakeholders to obtain right-of-way access. These steps are vital for legally operating on the designated land, protecting the environment, and ensuring safety throughout the project. Let us dive into the following topics. 1. Obtaining permits and approvals. 2. Environmental compliance and impact assessments. 3. Right-of-way, access and land acquisition. 4th, regulatory compliance and documentation. 5th, stakeholder engagement and community relations. 6. Finalizing permits and preparing for construction. Let us start breakdown in brief about the subtopics. 1. Obtaining permits and approvals. Before construction can begin, the project team must identify the specific permits needed at the local, state, and federal levels. These permits vary based on the project's location, the extent of environmental impact, and the construction activities involved. Some of the topics we picked up as examples include A. Environmental permits. Environmental permits are required for projects that impact natural resources such as wetlands, forests, or waterways. These permits ensure compliance with regulations designed to protect ecosystems, water quality, and wildlife habitats. Typically, these permits are obtained by the client. However, in some cases, the client may request the contractor to prepare the necessary documents, or they may handle the process through the consultant engineer. The approach often varies depending on the terrain and specific project conditions. B. Construction permits. General construction permits are often required for activities such as excavation, grading, foundation installation, and the erection of towers. These permits ensure that construction adheres to local building codes and safety standards. In certain terrains, civil work registrations and approvals must be obtained by the contractor before starting any construction activity. This process requires close coordination with the client to ensure compliance with local regulations. C. Road use and access permits. Road use and access permits are required when project access roads intersect with public roads or highways. These permits ensure the safe movement of vehicles and help prevent traffic disruptions. In particular, the contractor must obtain permits for the following scenarios: using roads during the heavy movement of equipment, crossing highways with machinery or construction activities, establishing temporary stores or camps near state highways, especially if they affect road activity, implementing signboards, or making modifications to roads for construction purposes. D. Road, railway, and waterway crossings. Contractors must obtain permits from the relevant local authorities for crossing highways, railways, or waterways. This involves submitting detailed designs and plans for the proposed crossings. All work near these crossings must be executed in accordance with the approved plans and profiles under the supervision of the respective authorities. E. Water usage. Permission must be obtained for using river water for construction activities. Similarly, if government potable water is to be used for purposes such as concreting or other construction needs, prior approval must be secured from the relevant authorities. F. Soil usage. Permission must be obtained in advance from environmental and other relevant authorities for using soil in activities such as filling and road construction. G. Store area. Permission must be obtained from local authorities to establish a temporary camp or store area, even if the property is privately owned. Relevant documents must be submitted as part of the approval process. H. Office and camp establishment. Permission and prior intimation must be provided to the relevant authorities for setting up offices and establishing staff camps. Compliance with local regulations is essential to avoid delays. I. HSE. As per norms, local permissions or intimation must be provided to the relevant authorities for HSE compliance. These permissions cover multiple aspects and require thorough documentation to meet regulatory standards. Once the necessary permits are identified, the project team submits applications to the relevant authorities. This process often includes: fill out detailed forms outlining the project scope, location, construction methods, and anticipated environmental impacts. Provide project plans, maps, environmental assessments, and engineering reports. These documents demonstrate the project's adherence to regulatory standards and help authorities assess potential impacts. After submission, the contractor must follow up with regulatory agencies to address any questions, submit additional information, and ensure timely processing of the applications. Some permits require public notice or community consultation. The project team may need to host public meetings or distribute notices to inform local residents and address any concerns. This process helps foster transparency and community engagement. Two, environmental compliance and impact assessments are typically conducted by the client before project initiation to secure route approval. For transmission line projects with significant environmental impacts, an environmental impact assessment (EIA) is often required. The EIA evaluates potential effects on air quality, water resources, wildlife, vegetation, and cultural heritage sites. This study is usually carried out by a consultant engineer based on the client's requirements. The EIA process typically includes A. Baseline studies. The consultant engineer, CE, or client-controlled agencies conduct baseline studies to assess the existing environmental conditions in the project area. These studies include evaluating factors such as soil quality, vegetation types, and wildlife habitats. B. Impact analysis. This process involves identifying potential impacts of construction activities, including habitat disruption, soil erosion, and noise pollution. It also includes proposing mitigation measures to address these impacts and outlining an environmental management plan, EMP, to be incorporated into the project contract. C. Regulatory review. The client submits the Environmental Impact Assessment, EIA, to the relevant environmental regulatory agencies for review and approval. This process may involve multiple rounds of review and revisions to ensure full compliance with environmental standards and regulations. D. Environmental Management Plan. An EMP details how the project will manage and mitigate environmental impacts. The plan includes strategies for erosion control, waste management, pollution prevention, and habitat preservation. Regulatory agencies may require the contractor to implement and document the EMP throughout the project. E. Obtaining special environmental permits. Certain aspects of the project may require special environmental permits, such as water resource permits. If the project impacts water bodies, such as rivers or wetlands, water resource permits are necessary to protect water quality and manage usage. Endangered species permits. If the project area is home to protected species, permits may be required to ensure that construction activities do not harm their habitats. Three, right-of-way access and land acquisition are handled by the client, contractor, or a third party, depending on the terms and clauses specified in the contract. Securing ROW often require access across private, public, and tribal lands. The agencies must work closely with the client to secure the necessary ROW by negotiating with landowners, government entities, or indigenous communities as required. The ROW process includes A. Land survey and route mapping. Once the route is confirmed, identify the land parcels that the line will cross. This provides an accurate layout for negotiating land access. B. Negotiating easements. An easement is a legal right to use a portion of land for a specific purpose. The agency project team negotiates with landowners to obtain easements, compensating them for the right to construct, operate, and maintain the transmission line on their property. C. Engaging with public land agencies. For ROW, across federal or state lands, the contractor must work with agencies such as the Bureau of Land Management or local state departments. These agencies review the project's environmental impact and ensure that public lands are used responsibly. D. Coordination with indigenous communities. If the project affects lands owned by indigenous groups, the contractor should engage in respectful and transparent dialogue to address cultural considerations and negotiate land access terms. E. Compensation and landowner agreements. The project team provides fair compensation to landowners in exchange for ROW access. These agreements are documented legally, outlining terms, compensation details, and ROW usage conditions. F. Legal documentation and ROW management. All ROW agreements are documented and legally recorded. The contractor also manages ROW upkeep, including clearing vegetation, monitoring erosion, and ensuring safe conditions along the transmission line route. Four, regulatory compliance and documentation. A. Compliance with local building codes. Transmission line construction must adhere to local building codes, safety standards, and industry regulations. The contractor ensures that all activities, from foundation work to tower erection follow these standards. B. Health and safety permits. Construction projects require compliance with health and safety regulations to protect workers and the public. The contractor may need permits related to occupational safety, hazardous materials handling, and construction site safety. C. Cultural heritage and archaeological permits. In areas with cultural or historical significance, permits are required to protect archaeological sites and cultural resources. This may involve conducting cultural heritage surveys and coordinating with cultural resource management authorities. D. Documentation, submission, and record keeping. Regulatory agencies often require detailed documentation of project compliance. This may include E. Permit applications and approvals. Keep copies of all permit applications, approvals, and communications with regulatory bodies. These documents serve as evidence of compliance. F. Inspection reports and compliance audits. Regular inspections by regulatory agencies may be required to verify adherence to environmental, health, and safety standards. The contractor should document inspection results, corrective actions, and follow-up reports. G. Progress and compliance reporting. Submit regular reports to the client and regulatory agencies to update them on project progress, environmental compliance, and row maintenance activities. These reports demonstrate the contractor's commitment to regulatory standards and transparent communication. Five. Stakeholder engagement and community relations. A. Community outreach and consultation. Transmission line projects may impact local communities, so the contractor should engage in community outreach to keep residents informed and address concerns. Public meetings, informational flyers, and local consultations help foster positive relationships and minimize conflicts. B. Addressing community concerns. Community members may raise concerns about noise, traffic, visual impact, or environmental effects. The contractor should address these concerns proactively, providing solutions and mitigation measures to reduce community impact. C. Ongoing communication with local authorities. Maintain regular communication with local government agencies, emergency services, and regulatory bodies throughout the project. This ensures that the project aligns with local priorities and addresses any issues promptly. Five. Finalizing permits and preparing for construction. A. Permit issuance and documentation. Once permits are issued, the contractor retains official copies in the project office. These permits should be easily accessible for reference during inspections and audits. B. Pre-construction checklist. Before starting construction, verify that all permits are in place, ROW access is secured, and compliance measures are documented. Conduct a final review of regulatory requirements to ensure readiness for construction. C. Coordination with client and regulatory agencies. Work closely with the client and regulatory agencies to confirm compliance and address any last-minute requirements. This coordination ensures a smooth transition from permitting to the construction phase. Obtaining necessary permits and approvals, ensuring regulatory compliance, and securing right-of-way access are essential steps for starting a transmission line construction project. With this, we come to an end on Topic 5 of Project Management on obtaining permits and approvals. Next, let us start with our sixth topic on project management is arranging logistics. After establishing the project office and site organization, and while obtaining necessary permits and approvals is in progress, it is essential to arrange logistics for the smooth transportation of materials, tools, equipment, and personnel. Identifying a reliable logistics agency and creating an effective transport plan will streamline the construction process, ensure timely delivery of resources, and support daily operations on site. Here's a detailed breakdown of how to coordinate and manage these logistics effectively. 1. Identifying and contracting a logistics agency. 2nd. Planning for material and equipment transportation. 3. Daily movement and on-site transportation coordination. 4th. Setting up access roads and site access points. 5. Material storage and inventory management on site. 6. Environmental and regulatory considerations for transportation. 7. Documentation and coordination with the logistics agency. 8. Communication and stakeholder coordination. Let us start breakdown in brief about the subtopics. 1. Identifying and contracting a logistics agency. This task is typically managed by the contractor's head team, while local coordination is handled by the project team. To better understand the process, let us outline the steps involved. The first step is to research and select a logistics agency with a proven track record in handling construction projects, particularly in remote or challenging areas. Look for agencies experienced in transporting heavy and oversized loads, coordinating complex supply chains, and meeting regulatory requirements. Assessment of capabilities. Ensure the logistics agency has the necessary capabilities to handle specific project requirements such as cranes, low-bed trailers for oversized loads, secure containers for sensitive materials, and a fleet of vehicles for regular transportation needs. Negotiation and contracting. Negotiate terms with the selected logistics agency, including rates, delivery schedules, service levels, and contingency plans. The contract should clearly outline expectations, key performance indicators, and procedures for managing potential delays or issues. Setting up communication channels. Establish direct communication channels between the logistics agency and the project team. Regular communication is essential for coordinating deliveries, managing schedules, and addressing any logistical challenges promptly. 2. Planning for material and equipment transportation. Inventory management. Create a detailed inventory list of all materials, tools, and equipment needed for each phase of construction. This list will guide the logistics agency in planning the transport of each item to the site. Material prioritization. Prioritize materials based on construction schedules. For instance, foundation materials will likely need to be delivered before tower components or conductors. By identifying these priorities, the logistics agency can schedule deliveries to align with project milestones. Delivery scheduling. Work with the logistics agency to develop a delivery schedule that aligns with the project timeline. Factor in lead times for materials, supplier availability, and the capacity of transportation routes. Transportation route planning. Plan transportation routes based on site access points, sea route and road conditions, and potential obstacles. For remote or challenging sites, consider alternative routes that accommodate oversized loads and minimize environmental impact. Oversized and heavy loads. Identify equipment and materials that require special handling, such as tower sections, large transformers, or cranes. For these loads, the logistics agency may need special permits, coordinate with regulatory authorities to obtain permits for transporting oversized loads. Permits ensure compliance with safety regulations, road restrictions, and weight limits. Escort vehicles. Arrange for escort vehicles to accompany oversized loads if required by local regulations. Escorts help manage traffic, clear obstacles, and enhance safety during transport. Equipment for loading and unloading. Ensure that cranes, forklifts, and other lifting equipment are available at the loading and unloading sites. This equipment is essential for handling heavy or oversized items safely. 3. Daily movement and on-site transportation coordination. Crew transport. Establish a plan for daily transportation of personnel to and from the site. Depending on the site's location and accessibility, this may involve shuttle services. Set up shuttle services from the project store or nearby camp to the work site. Shuttle services can reduce traffic congestion, minimize the need for personal vehicle use, and improve efficiency. Company vehicles. Provide company vehicles for site supervisors, engineers, and other key personnel who may need flexible transport options. Designate specific parking areas for these vehicles at the site. On-site material movement. Coordinate on-site movement of materials between storage areas, staging points, and work zones. Arrange for on-site vehicles, such as all-terrain vehicles, forklifts, or small trucks, to facilitate this movement. Staging areas. Designate staging areas where materials and equipment are organized for quick deployment to active work zones. Staging areas should be located close to each work zone to minimize the time and effort needed for material handling. Tool and equipment transport. Arrange for secure transport of tools and smaller equipment, either on a daily or weekly basis. Organize tools and equipment in labeled containers for easy access and safe handling. Safety protocols. Implement safety protocols for all transportation activities, including PPE requirements, safe loading and unloading practices, and speed limits on site. Safety briefings and signage reinforce these protocols and ensure that all personnel understand them. 4. Setting up access roads and site access points. Road assessment and planning. Assess the need for access roads to reach various points along the transmission line route. For remote or undeveloped areas, building access roads may be necessary to allow vehicles and equipment to reach the work zones safely. Route mapping. Map out the best routes to access each work zone, considering terrain, environmental impact, and ease of navigation. Where possible, use existing roads to minimize environmental disruption. Construction of access roads. If new access roads are required, plan and construct them with attention to drainage, stability, and durability. Grading and adding gravel or other stabilizing materials improves road quality and minimizes erosion. Developing site access points. Set up designated access points for entering and exiting the site. These points should be clearly marked and reinforced with gates or barriers if necessary. Access points help control site traffic, enhance security, and support efficient material flow. Maintenance of access roads. Schedule regular maintenance for access roads to ensure they remain passable throughout the project. This may include filling potholes, grading, and clearing debris. Regular maintenance reduces delays and ensures safe conditions for vehicles. 5. Material storage and inventory management on site. Storage facilities. Arrange storage areas for materials, tools, and equipment on site. These facilities should be secure, organized, and weather-protected as needed to preserve material quality. Storage containers. For smaller tools and equipment, use lockable storage containers. Labeled storage containers help keep items organized and reduce the time needed for locating specific tools. Outdoor storage for large components. Designate outdoor storage areas for large components, such as tower sections that do not require protection from weather. Ensure these areas are easily accessible and organized by material type. Inventory tracking. Implement an inventory tracking system to monitor the quantity and status of materials on site. This system helps the project team manage stock levels, avoid shortages, and schedule timely reorders. Material handling equipment. Arrange for forklifts, cranes, or other material handling equipment to move heavy items within the site. These tools are essential for loading, unloading, and organizing materials in storage areas. Six, environmental and regulatory considerations for transportation. Minimizing environmental impact. Plan transportation activities with attention to minimizing the project's environmental impact. For example, using established roads and pathways reduces the need for clearing new areas. Permits for environmental compliance. Ensure that all transportation routes and access road construction adhere to environmental regulations. If wetlands, protected areas, or wildlife habitats are affected, work with environmental agencies to obtain necessary permits and implement mitigation measures. Contingency plans for spills and accidents. Prepare contingency plans for dealing with transportation-related incidents, such as fuel spills, vehicle breakdowns, or accidents. These plans include emergency response protocols and contact information for relevant agencies. Seven, documentation and coordination with the logistics agency. Delivery tracking and documentation. Use delivery tracking systems to monitor material shipments. Require the logistics agency to provide regular updates on delivery status and inform the project team of any changes to the schedule. Daily coordination meetings. Hold daily or weekly coordination meetings with the logistics agency and project team to discuss upcoming deliveries, prioritize material needs, and address logistical challenges. Reporting and record keeping. Maintain detailed records of all material deliveries, equipment arrivals, and transportation activities. Accurate record keeping ensures accountability, aids in troubleshooting issues, and supports project tracking. Eight, communication and stakeholder coordination. Coordination with site supervisors. Maintain regular communication with site supervisors to coordinate material delivery schedules, update them on expected arrivals, and adjust plans based on site conditions. Engagement with local authorities. If transportation routes involve public roads, coordinate with local authorities to ensure compliance with regulations, manage traffic flow, and obtain necessary permits. Client updates and reporting. Keep the client informed about logistical progress, including material deliveries, equipment status, and any potential delays. Transparent communication builds trust and helps the client stay informed about project developments. With this, we come to an end on Topic 6 of Project Management on Arranging Logistic. Now let us start. Seventh topic on project management is route and detailed survey. During the establishment phase of a transmission line construction project, The root and detail survey and soil investigation are essential steps that provide critical data for the design, planning, and construction phases. These activities help finalize the transmission line's path, evaluate potential challenges, and assess the geotechnical conditions that may influence tower foundation design and placement. The detailed route survey is conducted to finalize the transmission line's path, identify any geographical or environmental challenges, and gather data needed for design adjustments. This survey helps optimize the route for efficiency, minimizes environmental impact, and ensures compliance with regulatory guidelines. We will cover this topic later in our construction chapter. Eighth topic on project management is geotechnical investigations, soil investigation. Its primary purpose is to assess the soil's characteristics and suitability to support transmission tower foundations. By understanding the ground conditions, engineers can design foundations that ensure the stability and longevity of the transmission line. Soil sampling. Samples are collected at proposed tower locations, usually through boreholes drilled at various depths. These samples provide insight into soil composition, density, and moisture content. In situ testing. Tests such as the Standard Penetration Test, SPT, and Dynamic Cone Penetration Test, DCPT, are conducted on site to evaluate soil strength and resistance. These tests help determine bearing capacity and other soil properties directly at the location. Laboratory testing. Collected soil samples are analyzed in a laboratory to identify grain size distribution, plasticity, compressibility, and shear strength. This data helps refine foundation design by providing a deeper understanding of soil behavior under load. Water table assessment. Identifying the water table depth is critical, as high water tables can affect foundation stability and require special design considerations. Geotechnical report. The results of the soil investigation are compiled into a geotechnical report, which outlines the soil characteristics at each tower location and provides foundation design recommendations based on the data. We will cover this topic in detail in our construction chapter. Ninth topic on project management is detailed design. During the project site establishment phase, it is crucial for the engineering and design team to focus on developing and finalizing the technical specifications for all major components of the transmission line. This includes designing towers, foundations, conductors, conductor accessories, and other critical components. The goal is to ensure that the designs align with industry standards, technical requirements, and safety regulations. Properly prepared designs are essential for maintaining project quality, operational reliability, and safety throughout the construction and operation phases. We will cover these topics in detail in our construction chapter. Chapter 6. Recap and Chapter 7. Overview. In Chapter 6, we covered essential areas including obtaining necessary permits and approvals, arranging logistics, route survey, soil investigation, detailed design. The remaining topics such as right-of-way, ROW, acquisition, procurement, and resource mobilization, implementing safety and environmental protocols, documentation submission and approvals, overview of construction phase execution, will be addressed and completed in Chapter 7. With this, we conclude Chapter 6. Some of these topics will be revisited in greater detail in our upcoming sections on construction activities. In our study program, we have consistently focused on the principles of professional ethics, covering all related topics in previous chapters. Now, as we move forward, we will begin exploring new topics starting with this chapter. From here, we will dive into legal compliance in corporate business for professionals and staff. This new subject will provide valuable insights, and we hope it will be helpful for all our viewers. Legal compliance refers to the adherence to laws, regulations, standards, and ethical practices that govern corporate activities. For corporate professionals, understanding and following these requirements is essential for maintaining the integrity, reputation, and success of both the individual and the organization. Legal compliance is a critical component in corporate governance and business operations, helping professionals navigate complex regulatory environments, avoid legal issues, and ensure ethical business practices. Let us understand the aspects of legal compliance for corporate professionals. These are following topics we will be covering in our chapters: understanding relevant laws and regulations, corporate governance and ethical standards, compliance with employment laws, data privacy and protection, anti-corruption and anti-bribery laws, environmental compliance, financial and tax compliance, intellectual property, IP, compliance, implementing legal compliance in the workplace. Understanding relevant laws and regulations. Corporate professionals must be familiar with the specific laws and regulations that apply to their industry and role. These can include labor laws, environmental regulations, data protection laws, financial reporting requirements, and industry-specific guidelines. Examples: for financial professionals, compliance with the Sarbanes-Oxley Act or International Financial Reporting Standards (IFRS) is critical. In the tech sector, professionals must follow data privacy regulations like the GDPR, General Data Protection Regulation, or CCPA, California Consumer Privacy Act. This is a foundational aspect of legal compliance for corporate professionals. This understanding ensures that professionals are aware of the legal boundaries within which they operate, helping to avoid potential violations, penalties, and legal issues. Each industry has its own set of regulations, and within these, professionals must navigate specific laws that apply to their roles and responsibilities. Today's quote is from Potter Stewart. "Ethics is knowing the difference between what you have a right to do and what is right to do." The quote underscores the distinction between legal rights and ethical responsibilities. It suggests that just because an action is legally permissible doesn't necessarily mean it is morally or ethically appropriate. Ethical decision-making involves considering the broader impact of our actions on others, even when those actions are within our legal rights. As we wrap up our session, I encourage you to subscribe and hit the bell icon so you won't miss any of our upcoming chapters. It's your gateway to mastering transmission line supervision. That brings us to the end of today's Chapter 6 on project management. Next time, we'll dive into the concluding part on project management. Until then, take care and thank you for watching.